Okay, first thing I'm going to do is put the forces on here. I always put the weight on first, so the weight comes straight down. That's 50 G. I want a normal contact force, which is the second thing I always put on there. That's R. I've got this force here, so I'm going to label that X, is already labelled. And finally, I've got tension in the string rope up here, so tension there. And it says we're resolving forces on the block vertically, so I don't even need to do anything, I just need to resolve vertically. And it's not going anywhere there, so the upward forces must equal the downward forces. What have we got going up? We've got R, and we've got a component of this. Okay, that's why I split this force up into a horizontal component and a vertical component. And this bit here is the bit we need, and that will be T sine 72, because it's opposite. So that's going to give us R plus T sine 72, and that's the upward forces, and that's got to equal downward force, which is 50 G. And that is a relationship between T and R, so I can leave it at that. Part 2 is given that the block is on the point of lifting off the ground. So on point of lifting off ground, I'll probably write this down. The ground, that implies that R will equal 0, because it's just touching. So therefore that will give me that T sine 72 equals 50 G. So T equals 50 G divided by sine 72, which is 515.21648, which equals 51523 significant figures. That's good. And hence find the value of M. So now I've got this bit here, so I can put the other forces on here. I've got that will be mg, and because it's a smooth pulley, the tension, the forces either side are the same, and so there'll be a tension here, equal tensions the other side of the smooth pulley. So I can resolve vertically, and that again will give me up equals down, and so we've got T equals mg. We just worked out T, 515.216. Don't forget to keep as much accuracy. That equals mg. So m equals 515 divided by 9.8. So m equals 52.573. And then part 3. So we found the value of M. Part 3, by resolving the forces on the block horizontally, write down the thing between T and X. So we're going to resolve horizontally, and that means that we'll have X will equal T cos 72. That's this part of the force here, that part there. So X equals T cos 72. We know what T is, so X equals 515 times by cos 72. So X equals 159.21065, which equals 159 newtons to 3 significant figures. And that's question 3 done.